And welcome back, guys. Today we have a little bit different case that you used to watch on this channel. This is an old lady with osteolytic lesion of the frontal bone of the skull. I will make a segmentation of the bone of the skull. I will make the segmentation of the soft lesion. This is a metastasis from the breast carcinoma, and I will try to make a segmentation of the brain. And to be honest, I'm not sure what is the plan here, because after I make segmentation and make models of the bone and the lesion and the brain, I will meet with maxillofacial and surgeon and neurosurgeon, and together we will decide what they want to do. Do they want to have just a model? Do they want to have a model for pre-bending of the plate, or maybe to have a cutting guides? We could make graft for the cover the osteotomy place. I'm not sure. So I'll perform a segmentation, and we will see in a few next days what we will decide. So I have adjusted a window for better delineation of the tumor mass and the bone and the brain, and now I will start to do the segmentation. I will start with the bone. So after I finished the segmentation, I repaired some artifacts on the model of the skull. I have put a part of the frontal bone and the orbit to the 3D printer, and it was printed during the night. And in the morning, I have cleaned the supports and went to see the neurosurgeon and the maxillofacial surgeon. And here is the plan. The idea is to have centimeter from the diseased bone. I have to be careful because the inner tabula, the defect in inner tabula is bigger than on the outer tabula. So yeah, I will try to do a cutting guide according to this plan. So for this project I will use two modeling software. First is Blender, as you can see, and the second one is Mesh Mixer. For the beginning I will import the model of the skull. Okay, and now I will perform decimate modifier because I want to reduce the number of vertices and the facets. So let's see, 0.4 is good, will be good or not. Okay, it is. So hit apply, and the next step is I want to make a mirrored model of this of contralateral side, and I want to have two models, one with defect and the other one without defect, so that one will be used for making the graft. So let's duplicate the model, and also this copied model will used as reference point when performing the mirroring. Okay, let's see like that. Good. Okay. So we will cut the skull in half. I want to delete all the vertices that are not connected to this right part of the skull. And let's do the mirroring. Okay, turn on. Okay, this little discrepancies between these two skulls I will repair it in the mesh mixer. So okay, let's hide that one. Great. Okay, export it and name it as you wish. Let's name it as number 2, and we will name and export the native skull as number 1. Okay, and now we will switch to mesh mixer. And I open the skull in mesh mixer. I want to make a plain cut. Oh, too much. Okay. This is okay. And now append the second skull. Let's do the plain cut here. Now we have two skulls. Let's try and to model. Actually, from the inside, it doesn't look that bad. Let's try. Okay. Let's do a little bit of smoothing. Okay, this is more or less. Okay, this is more or less okay. I don't want to have big discrepancies between these two models, but looking at, let's see the inside. Let's try to flatten. There is no. Okay, now I want to design the cutting guide. Let's hit the select. Let's see. As said in the plan, I want to have at least 1 centimeter of the margin between the lesion and. Okay, let's select. Let's undo the process, and I have to. Let's undo the process, and I have to make more space over here. Because the tumor is bigger on the inside of the skull than outside of the. Now let's see if we have a safe margin. I think that we do have it. Yes. Okay, now I have the contour of the cutting guide. Let's do the offset. Let's place 3 millimeters. Okay, here we have some artifacts. So let's select this outer skin. Let's do the modify smooth boundaries, accept, and let's, oh, this looks nice. This looks nice. Let's unselect. Let's try up. Let's delete this part. Okay, delete. Let's hit again smooth boundaries. Accept. Now it looks okay. Unselect everything. Okay. Let's do the same here. This looks nice. And now we will clear selection, export it as number 3. And now we will import it here. Let's delete unconnected vertices. And connect facets. Let's see. Oh. Okay, now we're finished. Let's export it back to as number 3. I will add holes for screws. I'm thinking of placing maybe 4 holes with 3 millimeter diameter. So one over here. Let's flatten the healthy scaffold for the graft so we have a little bit more. And the next step is making a graft. So I tried several ways. One of them was I tried to extrude this inner part, add it to thickness, and I wanted to make like cutting plane. The boolean didn't work. I don't know why. I tried the same thing in the mesh mixer. It didn't go. Then I tried to make just a plane. Again, it was too hard. It didn't turn out well. I thought that maybe first I should make a defect, and according to defect I should make a guide. So I was thinking of starting it all over again. I think that I have found a solution. If you have any comments, suggestions, please write them down. I'm eager to hear, because this is pretty well. I couldn't find a solution beside this one. So the plan is to select the only part that I want to keep, both inside and the outside, and to delete the rest of the bone. I will trim the edges into the mesh mixer and connect the two parts, and I will have a graft. So let's start. Okay, first I will delete most of the bones, because it will only make hard for me to see the parts that I need to see. So everything, I will delete everything. Try to delete most of the bones you can. Watch out not to delete the parts you need to keep. So let's save a little bit of this bone. And again, now you select the parts that you want to keep. Try to be, it is hard to see, but this is the inner side of the cutting guide. Try to be as perpendicular you can. Yeah, this is maybe this is easier for me to see. Maybe you'll say this is not precise, but I'm not afraid, because I'll do some of the modifying of the graft according to the native bone and the cutting guide in the mesh mixer. You'll see later that, and it will fit perfectly. this. Now let's export it, and I will import it inside the mesh mixer. And I open it and import it inside the mesh mixer. I will append guides and skull. Okay, so let's turn everything and let's do some modeling. Actually, I should import a diseased skull. Let me do the plane cut. Yeah, I'm totally satisfied how this looks. Let's do some modeling. So I decided to move this inner part of the graft a little bit more outside, just in case not to protrude into the intercranial space. It won't, this is maybe a few millimeters, but just to be sure. Okay, now I can say that I am satisfied, and now I will export this part into the. Now when I import it in Blender, I will connect these two. Okay, and okay, and this should be graft. I will make a mold for it because we are planning to fill it with bone cement, the PMMA, during the operation. So I will save it and now I will cut the cutting guides in two parts, over here and over here. Okay, let's name this one as cutting guide orbit.
And hi again, I've printed a guide as it should look. Today I went to visit and had a meeting with a surgeons, so everything is satisfying for them. The only thing that crossed my mind, and I told them that maybe I should change the angle of the screw hole where the orbital part of the cutting guide will be fixed, so it is hard for the surgeon, it will be hard for the surgeon to fix it under this angle. So I will try to make a hole in this angle over here, so like that, same, maybe same for the more distal hole over here. And if you try to compare, this is a graft, it it fits the cutting guide. Okay, there was written marked the places of the holes for the screws, and the diameter is 2 mm. So that's the plan.
And now let's proceed with making this screw guide angle a little bit different. We'll make the changes for both. So select the graft. Let's select the facets. If you want to delete like that, delete the facets. let's do the same for okay. Now we closed the holes. Okay, now let's add same holes but in the different angle. Okay, let's put it somewhere here at this angle. Okay, like that. Add a cylinder. Let's make 3mm screw hole. Let's add. See, when approaching from this side, let's see if this. Okay, I think this is good angle. I think that this angle should be better for surgeons to fix the guide to the skull. We are finished with this. Let's hit the make manifold button. Okay, it is manifold, and save the process. Okay, we have a graft. We have a skull. I will check the 3D printed model. Okay, the hole should be somewhere here, over here, and over here. Okay. The neurosurgeon asked me to make 2mm hole, 2mm holes. I'm not sure if I will make the full thickness hole, because the next step is to make a mold for this graft. So I think it will be hard to have that kind of model, because I want to make a plane of the two parts, like somewhere here through the between the inner and outer tabula. The surgeon didn't tell me. The surgeon didn't tell me how far the hole must be from the edge of the graft, so I took it around 3mm. Actually, that is the measure. now we will make a mold for the and now we will make I will make a copy of this graft, and I will add a hole for pouring and one as a chimney, and then I will cut actually Boolean difference in the cube, and then I will cut the mold into the two pieces. Why I'm doing this because for 3D printing of the molds we will hire a outsource company, so unfortunately we have to pay everything by ourselves, and I really don't want to have access. Yes, I forgot to make bouillon with the grafts. Maybe I could reduce some of the material over here. Yes, I will do that later or now. Now let's add. Now let's add some. But now this will. But now this will be our source company with Stratasys 3D printer. Maybe I could go on 0.1, but I'm not sure, so I just don't want to be, let's say, oh, sorry. Okay, so what you want to do is, so this is the result. You see, okay, if I choose one, these points will help place these two parts, and I'm planning that we will have some kind of clamps holding together these two parts. From this side we will pour the surgical cement, bone cement, and this will be the chimney. I hope it will work. So let's try to reduce more of the material. One half and the other half.
The first picture shows the perfect fitting of the surgical guide on the frontal bone. The maxillofacial surgeon had a little bit harder job to do the osteotomy on the orbital part and the base of the skull. And the final result of the graft placement was a little bit sketchy on that side because they couldn't perform the perfect osteotomy on the base of the skull. The second picture is showing me clamping the two-part mold. This was the best approach because it turned out that the bone cement polymerized really quickly, so we couldn't do the injection yet. We put some of the bone cement between the two faces of the molds and clamp them together. The third picture is a close-up of the process. You can see the excess material exiting through the sides of the mold. Now you can see me removing the excess material from the sides of the graft. This is the final look of the graft before the implantation. And the last picture is showing the graft implanted and fixed into the place of the previously made skull defect. The fitting in the frontal bone is excellent, I could say, but on the control CT scan of the head after the surgery, there was a slight mismatch between the graft and the native bone on the base of the skull due to the unfavorable osteotomy of the skull base.
Thank you for watching, and this was an interesting case, a little bit complex because the region that was diseased and the osteotomy, where should osteotomy be performed, was orbitofrontal. If it was only a defect on neurocranium, it would be easy to make a graft and the mold for graft, and also it will be easier for make the surgical guides. Until the next time, bye bye guys.